Welcome to this puzzle session. Here is the problem. We have 101 points. 101 points are placed inside a 1 cross 1 square. So the square has length and breadth 1 unit. We want to show that 3 of these points form a triangle of area at most that much. So heuristically, if you place too many points in a small space, 3 of the points will form a triangle of small area. And this is a quantitative version of that heuristic. Okay, so as usual, you're encouraged to pause the video before we look at what I'm going to discuss. And with that, let us move to the solution. Okay, so what we are doing is we have this unit square, which we have partitioned into 50 chambers. So from the horizontal side has been divided into 10 equal parts, each of width 1 by 10 units. And the vertical side has been divided into 5 equal parts, each of width or length 2 by 10. So we have 50 chambers and we are placing 101 points in 50 chambers. What we want to do is we want to associate a unique chamber to each point. So if a point falls within the interior of a chamber, then there is no issue. We will associate that particular chamber with that point. But it may happen that a point is on the boundary or a point is even somewhere here. Then you make an arbitrary choice for that particular point. So for instance, suppose a point is here, then just choose one of these 4 chambers and associate one of those chambers with this point. So what are we doing? Formally, what are we doing is we are having a function from the set of all the points to the set of all the chambers. Okay, so we can define such a function. For each point that is there are 101 points. So P is a set of size 101. And to each point, we can associate a unique chamber in which it lies. Right? And the ambiguity that may arise is if a point is, let's say, sharing the boundary of 2 chambers or is on a corner point, then you make an arbitrary selection. You send that point to either this one or that one or this one or that one, and that's okay. So you get a function from a set of size 101 to a set of size 50. And therefore, some 3 elements of this set must map to the same thing. This is the pigeonhole principle. If you are placing 101 pigeons in 50 cages, then some 3 pigeons must share a cage. So for the sake of understanding first, you may assume that for the moment that no 3 points or no point lies in this white part. Every point is squarely within some chamber. Okay. So some 3 points must share a chamber, and let's say it is that chamber. So as soon as you have 3 points in a chamber, let's say that chamber has 3 points, then we want to say that this triangle that you get here, this one, has area at most 0.01. Why is that? Because the area of the whole chamber is 0.02. It's 2 by 10 times 1 by 10. So the area of the chamber is 0.02. And if you choose 3 points within this chamber, what is the maximum area that you can get? You can get at most half of it. And that I don't want to prove rigorously, but here is the main thing. The greatest area that you can make by using 3 points in the chamber is when you choose a triangle of this kind. And this triangle has half the area of the chamber and hence has area 0.01. So that's the main idea. Once you can show that 3 points must share a chamber, you are done, because those 3 points will have area, or the triangle formed by the 3 points will have area at most 0.01. So I hope this was clear. The only ambiguity that arose in the entire argument was what happens when a point is lying on one of these white regions, but there you just make an arbitrary selection. You want to define a function from points to cages or chambers, So if a point is here, you just choose which chamber you like more. You write this, you like that one, you send it there, or you like that one, you send it there. Okay, so I hope this was clear. And as usual, like, comment, share, subscribe, and I will see you next time.